This episode is proudly sponsored by the architectural wonders of question design. Every survey question is a miniature blueprint, a delicate scaffolding constructed from logic and linguistics, designed to hold the fragile edifice of an opinion. When perfectly balanced, it guides the respondent to a precise truth. When flawed, it becomes an Escher-like staircase, leading to delightful yet utterly uninterpretable realms of ambiguity. It's a testament to the grand ambition of mapping the human mind, one carefully constructed sentence at a time.
Welcome back to the Deep Dive and our series on survey research, where we are exploring the diagnostic mastery and analytical expertise that elevate medical laboratory scientists to true partners in healthcare and research. In our last episode, we covered the foundations of survey research and discussed why it's such a powerful tool.
Our last episode was our primer, the why we'd ever step away from the bench to conduct this kind of research. This episode is all about the how. We're moving from theory to practice and focusing on building the single most critical component of any survey project, the instrument itself.
That's right. Today, we're doing a deep dive into the art and science of survey instrument design. And this is where the rubber really meets the road, because as we discussed, whether you're a manager trying to gauge employee satisfaction, a lead laboratory scientist investigating pre-analytical errors on a specific floor, or part of a team assessing a new safety protocol, the quality of your answers depends entirely on the quality of your questions.
It is the ultimate pre-analytical variable for this type of data collection. We live by the principle of garbage in, garbage out with our patient samples, and it is no different here. A poorly constructed questionnaire, just like a poorly calibrated pipette or a reagent with interfering substance, will inevitably yield flawed and unusable data. Today, we're going to give you the QC principles to make sure that doesn't happen.
Our plan is to walk through this methodically. First, we'll lay the foundation with the core principles of writing good questions. Then we'll look at the different types of questions you can use, the tools in your toolkit. We'll get into the nitty-gritty of designing scales to measure complex ideas like satisfaction. And finally, and this is so critical, we'll cover flow, formatting, and the lab equivalent of validation, pre-testing, and piloting.
It's a journey from a research idea all the way to a finished, validated instrument ready for deployment. To build a good survey, we have to start with its smallest component, the individual question. What are the fundamental principles of a well-constructed question?
I think the absolute number one principle, the one that everything else builds on, is clarity. If the person taking your survey doesn't understand what you're asking, the answer is meaningless. It's a failed test. We have to use simple, direct language, and, most importantly for our field, we have to mercilessly eliminate our own jargon.
That is such a huge point for us in the lab. We might think a term like critical value notification is straightforward, but if you're surveying a resident or a nurse, do they call it that? Or do they call it panic value, calling it critical, or something else entirely? If you use your internal lab term, you might confuse them, and they'll either skip the question or guess.
A perfect example. Ambiguity is the enemy. Words we use casually, like often or frequently, are data black holes. If I ask a laboratory scientist, how often do you have to perform maintenance on the hematology analyzer? One person might think often is twice a week, another might think it's twice a month. The data is non-standardized and basically useless for comparison.
So how do you fix that? You add a concrete frame of reference. Instead of how often, you ask, in a typical month, how many times you perform unscheduled maintenance on the hematology analyzer. You give them a number to provide, or you provide clear options. Less than once a month, 1 to 3 times a month, once a week, more than once a week. Now you have data you can actually tabulate and analyze.
And that ties into the next principle, conciseness. Questions should be as short as they can possibly be without losing their meaning. Long, winding questions cause respondent fatigue. People get tired, they stop reading carefully, and they start satisficing, just picking an answer to get it over with. It's like trying to read a long, dense SOP. After a few pages, your eyes glaze over.
The next principle is about bias. It is so easy to accidentally influence the answer, and we have to be vigilant about creating neutral questions. There are 2 major pitfalls here: leading questions and loaded questions.
Let's break those down. A leading question subtly nudges the respondent toward the answer you want. Let's say management just spent $1 million on a new automation line. A manager might write a question like, "Don't you agree that the new automation line has greatly improved turnaround times?" That "don't you agree" part is practically begging for a yes.
It's putting your thumb on the scale. A neutral version would be, what has been the impact of the new automation line on turnaround times? And then provide options. Greatly improved, slightly improved, no change, slightly worsened, greatly worsened. That allows for an honest answer.
Then you have loaded questions. These questions contain emotionally charged words or make an assumption about the respondent. A classic loaded question would be something like, "What do you see as the primary benefit of our lab's superior quality control program?" The word superior is the problem. It presupposes a fact that the respondent might not agree with.
A less obvious but common loaded question in our world involves assumptions. Imagine a question, on which shift do you find it most difficult to get a phlebotomist for a redraw? This assumes the person has difficulty getting a phlebotomist for a redraw. The better way is to use a filter question first. Question 1. In your experience, do you ever have difficulty getting a phlebotomist for a redraw? If they say yes, then you present them with the follow-up question about which shift.
That's a great segue into the last major construction error, the double-barreled question. This is when you ask two different things in one question, but only allow for one answer. It's the analytical equivalent of trying to measure both glucose and creatinine in the same cuvette with one reagent. The result is uninterpretable.
For sure. You see these all the time. A question on a lab satisfaction survey might say, please rate our courier service on its speed and friendliness. Well, what if the courier is really fast, but surly and unpleasant? Or he's the nicest guy in the world, but he's always late? The respondent can't answer that honestly. The data is useless because you don't know which part of the question, speed or friendliness, they were reading.
And the fix is so simple. Just split it into two separate questions. One asks about speed, the other asks about friendliness. Now you have clean, actionable data. You might find out you have a training issue with courtesy, not a logistics issue with speed.
So to recap the foundation, be clear, be concise, be neutral, and ask one thing at a time. If you just master those 4 principles, you are already 90% of the way to writing a good survey.
Okay, so we know how to craft a single high-quality question. Now let's talk about the different formats we can use. This is our toolkit, the different types of questions we can deploy depending on what we want to measure. The 2 primary categories are open-ended and close-ended.
Let's start with open-ended questions. These are the questions that provide a text box and ask the respondent to answer in their own words. They're qualitative. They don't give you numbers, they give you stories, opinions, and context. They are fantastic for exploratory work where you don't know what the possible answers are.
A great example would be at the end of a survey. Do you have any other suggestions for improving the specimen receiving process? You might uncover an issue you never even thought of asking about. It's like the comments field on an incident report. That's where you often find the real root cause. The richness and the potential for unexpected discovery are the huge strengths of open-ended questions.
But that strength is also their weakness, especially for those of us who like clean, quantitative data. The data from open-ended questions is messy. It's time-consuming to analyze. You have to manually read through every response and perform something called thematic analysis or coding to find patterns. If you have 500 responses, that's a monumental task. They can also cause survey fatigue if you use too many.
So you use them strategically. In contrast, you have close-ended questions, which are the workhorses of quantitative survey research. Here you provide the respondent with a list of answers to choose from. The data is immediately quantitative, easy to tabulate, and simple to analyze. You can quickly see that 72% of respondents chose option B.
And within close-ended questions, there are a few key types.
This episode is proudly sponsored by the architectural wonders of question design. Every survey question is a miniature blueprint, a delicate scaffolding constructed from logic and linguistics, designed to hold the fragile edifice of an opinion. When perfectly balanced, it guides the respondent to a precise truth. When flawed, it becomes an Escher-like staircase leading to delightful yet utterly uninterpretable realms of ambiguity. It's a testament to the grand ambition of mapping the human mind, one carefully constructed sentence at a time.
Welcome back to the Deep Dive and our series on survey research, where we are exploring the diagnostic mastery and analytical expertise that elevate medical laboratory scientists to true partners in healthcare and research. In our last episode, we covered the foundations of survey research and discussed why it's such a powerful tool.
Our last episode was our primer, the why we'd ever step away from the bench to conduct this kind of research. This episode is all about the how. We're moving from theory to practice and focusing on building the single most critical component of any survey project, the instrument itself.
So you use them strategically. In contrast, you have closed-ended questions, which are the workhorses of quantitative survey research. Here, you provide the respondent with a list of answers to choose from. The data is immediately quantitative, easy to tabulate, and simple to analyze. You can quickly see that 72% of respondents chose option B.
Within closed-ended questions, there are a few key types. The simplest is the dichotomous question. It offers only two choices: yes, no, true, false, pass, fail. We use this concept all the time. Did the QC for the morning run pass? Yes or no? It's unambiguous. But its simplicity can also be a flaw. Asking, are you satisfied with the LIS with only a yes or no option loses a massive amount of nuance. Most people are probably somewhere in the middle.
For more nuance, you move to multiple choice questions. Here you offer a list of options. The key design principle is that the options should be mutually exclusive, they can't overlap, and collectively exhaustive, meaning they cover all possibilities.
Let's make that concrete. Say you're asking about job roles. Your options can't be bench lab scientist and chemistry lab scientist if a person can be both. That's not mutually exclusive. And to make it collectively exhaustive, you almost always need to include an other please specify option because you can never anticipate every possibility.
A very powerful variation is the select all that apply multiple choice question. For example, which of the following analyzers have you been trained on? Select all that apply. This lets you understand combinations of skills or behaviors.
But to really measure attitudes and perceptions, the most powerful tool is the rating scale. These questions don't ask for a simple choice. They ask respondents to place their opinion on a continuum. This is how we capture the degree of feeling.
And there are two types everyone should know. The first is the Likert scale. This is probably the most famous scale in the world. You present a statement and the respondent rates their level of agreement, usually on a 5-point scale. Strongly agree, neutral, disagree, strongly disagree. My supervisor provides me with constructive feedback. You can immediately quantify the responses and see the distribution of agreement.
The other common one is the semantic differential scale. This one is great for measuring perceptions of a brand, a product, or a service. Instead of agreement, it uses a scale anchored by two opposite adjectives. You might ask staff to rate the new LIS on a 7-point scale between easy to use and difficult to use, or between modern and outdated. It captures the cognitive or emotional meaning of something.
So a well-designed questionnaire will use a strategic mix. It might use multiple choice questions for demographics, Likert scales for attitudes, and maybe one or two open-ended questions at the end to catch anything that was missed. Choosing the right question type for the job is essential.
All right, this brings us to a more advanced topic, but it's crucial for measuring complex concepts. We talked about using a Likert scale for a single question. But what if you want to measure something big and abstract, like lab employee morale or culture of safety?
You can't capture something that complex with a single question. Asking, do you think we have a good culture of safety is not going to get you reliable or valid data. A person's answer could be based on anything. This is where we need to design scales, which are composite measures made up of multiple questions, which we call items. It's the survey equivalent of ordering a panel
instead of a single test. To understand liver function, you don't just order an ALT, you order a full liver panel.
That is the perfect analogy. Each item in the scale is like a different test in the panel. It measures a slightly different facet of the same underlying construct. You might have one item about feeling comfortable reporting errors, another about management's response to errors, and a third about the availability of PPE. You then combine the scores from all these items, usually by averaging them, to get one much more reliable and nuanced overall score for culture of safety.
The design of that scale is paramount, and it brings us to the two most important concepts in all of measurement theory, concepts every MLS lives and breathes every single day: reliability and validity.
This should be home turf for our audience. Let's translate this directly. Reliability is precision. It's about consistency. If you run the same sample 10 times, do you get the same result every time? A reliable scale is the same. If a person took your survey on Monday and again on Tuesday, assuming their actual opinion hasn't changed, a reliable scale should give you the same score. It's a stable measurement.
And a key type of reliability for scales is internal consistency. This is a statistical measure of whether all of the items in your panel are actually measuring the same thing. Do they correlate with each other? If your scale is measuring job satisfaction, you'd expect that someone who scores high on satisfaction with pay would also tend to score high on satisfaction with coworkers. A statistic called Cronbach's alpha is the QC check we run on our scale to ensure all the items are hanging together properly.
Okay, so if reliability is precision, then validity is accuracy. Is your instrument measuring what it actually claims to be measuring? This is about getting the correct result, not just a consistent one. You could have a scale that's incredibly reliable, but not valid at all.
Absolutely. I can build a thermometer that reads 5 degrees too high every single time. It's perfectly reliable, precise, but it's not valid. It's accurate. A survey can do the same thing. I might create a scale I think measures burnout, but what if it actually just measures general unhappiness or whether someone is having a bad week? It would not be a valid measure of the clinical concept of burnout.
There are different ways to assess validity. The most basic is face validity. At a glance, does it look like it's measuring the right thing? A more robust form is content validity. Does your scale cover all the important aspects of the construct? A burnout scale that only asks about exhaustion but ignores cynicism and reduced efficacy would have poor content validity.
The gold standard is construct validity. This is a deep dive to see if your scale behaves the way theory predicts it should. For example, a valid scale for job satisfaction should have a strong negative correlation with a scale that measures intent to quit. If it doesn't, something is wrong with your instrument. You're checking to see if your measurement fits into the known universe of related concepts, just like a new lab test result should make sense in the context of a patient's overall clinical picture.
So when you're building a true scale, you're not just writing questions. You're developing a scientific instrument and then performing rigorous testing to ensure it's both precise and accurate. For any serious research, you can't just skip this step.
All right, we've designed our questions, selected our types, and even built a valid and reliable scale. Now we have to put it all together. The flow and formatting of the questionnaire are critically important for keeping the respondent engaged and ensuring high-quality data.
The structure, or flow, needs to be logical. A good survey feels like a conversation, not an interrogation. The best practice is typically a funnel approach. You start with broad, general, and easy-to-answer questions to warm the respondent up and get them engaged.
You would not start a survey with, "Please enter your employee ID number." That's intrusive and feels like a test. Instead, you start with something general and non-threatening, like, "Overall, how would you rate your experience working in the core lab this past year?" Then you can gradually funnel down into more specific topics, questions about specific instruments, then about specific policies, and so on.
It's also vital to group questions by topic. Don't ask one question about hematology, then jump to a question about PTO policy, then jump back to a question about chemistry. That's cognitively jarring. It forces the respondent to switch mental gears constantly. Keep all the questions about staffing in one section, all the questions about equipment in another. It creates a smooth, logical path.
And a huge part of that logical path is placing your sensitive questions at the end. This includes most demographic questions, age, salary, even department.
people are much more likely to answer personal questions after they've already invested time and effort into the rest of the survey. Ask for their age and salary on page 1, and you'll see a massive drop-off rate.
An essential tool for creating a smooth flow, especially in online surveys, is skip logic or branching. This is the programming that ensures respondents only see questions that are relevant to them. We mentioned this earlier with the filter question. If a laboratory scientist says they don't work in microbiology, the survey should automatically skip the entire section of questions about a new microbiology media.
Forcing someone to answer or skip past the dozen questions that don't apply to them is a cardinal sin of survey design. It's frustrating, it makes them feel like you wasted their time, and it's a great way to get them to quit your survey. In an online survey, this should be invisible and seamless.
Finally, there's the visual presentation, the formatting. A clean, professional, uncluttered layout is just more inviting. Think about a well-designed LIS screen versus a cluttered one from the 1990s. Which one is easier to use and less prone to user error?
Use of whitespace is key. Don't cram everything together. Use a clear, legible font. Be consistent in how you format questions and answers. Make a clear visual distinction between the question, any instructions, and the response options. It just makes the whole task less burdensome and reduces the chance that someone accidentally skips a question. And for online surveys, a progress bar is a must-have. It's a simple psychological tool that shows the respondent how much they've completed and how much is left. It manages their expectations and motivates them to get to the finish line. It's been shown to significantly reduce survey dropout rates.
Okay, we've come to what I believe is the single most important stage in this entire process, and also the one that is most often skipped by amateurs. We've drafted our questions, organized them, and formatted everything beautifully. It exists on paper, but it's still a theoretical tool. We need to do our quality control. We need to talk about pre-testing and piloting.
I could not agree more. This is, without question, the step that separates professional research from a casual pull. Skipping this is the equivalent of developing a brand new assay in R&D and then running it on patient samples without ever doing a full validation study. You would never, ever do that. It'd be a massive violation of every principle we hold. A survey instrument is no different.
Let's define the terms. Pre-testing is about evaluating the individual questions. The best way to do this is with a cognitive interview. You sit down with a handful of people, maybe 5 to 10, who are like the people you plan to survey. You don't just have them take the survey, you ask them to think out loud as they answer each question.
And what you learn is incredible. They'll say things like, when you use the word turnaround time, are you talking about from the time of collection or the time of lab receipt? Because that means two different things to me. And right there, you've discovered a critical ambiguity in your question that would have destroyed your data. Pre-testing is where you find your confusing jargon, your double-barreled questions, and your biased wording.
After you've refined the questions based on that pre-testing, you move to the pilot study. If pre-testing is like checking each component of the instrument, piloting is the full dress rehearsal. It's your validation run. You administer the entire survey, from the invitation email to the final thank you page, to a small sample of people who are representative of your target population.
This tests everything. It tests the survey instrument itself. It tests your skip logic to make sure there are no broken paths. It tests your technology. Does the survey work on a mobile phone as well as a desktop? Most importantly, it gives you a realistic estimate of how long the survey actually takes to complete. You might think it takes 10 minutes, but your pilot test might reveal it actually takes 25, which means you need to cut it down to avoid respondent fatigue.
The pilot test is your chance to find and fix any problem with the instrument or the process before you invest the time and money into the full study. Discovering that a key question is flawed after you've already collected 500 responses is a catastrophic failure. It can invalidate your entire project.
Let's just summarize the benefits because they are so critical. Piloting helps you refine question wording, check your survey flow and skip logic, get an accurate completion time, test your deployment technology, and gauge respondent reactions to sensitive questions. It is the insurance policy that ensures the data you're about to collect will be clean, valid, and able to answer your research questions. It is your survey QC.
It really is. It's about treating survey design with the same scientific rigor we apply to everything else we do in the laboratory.
So to pull this all together, we've seen that a questionnaire isn't just a list of questions. It's a scientific measurement instrument. Every choice we make, from the wording of a single question to the use of a progress bar, is an analytical decision that impacts the quality of our final data.
We've walked through the fundamentals of writing clear, neutral questions. We've looked at the different tools like open-ended and close-ended formats. We've demystified scale design by relating reliability and validity to our core lab concepts of precision and accuracy. And we've emphasized the non-negotiable importance of QC through pretesting and piloting.
The next time you're asked to create or even just take a survey at work, hopefully you'll look at it with a more critical eye. You'll see the double-barreled questions and the leading phrases, and you'll understand that the data coming out of it might be suspect. More importantly, when it's your turn to collect this kind of data, you'll now have the framework to do it right.
It's another example of how the principles of quality and analytical rigor we practice every day at the bench can be applied to so many other areas. It's about being a scientist in everything we do.
A perfect place to end. Be sure to follow us up on the next episode where we dive into sampling strategies and data collection.
Sounds like a plan. Thanks for tuning in. We'll see you next time.